Okay, this is one of the few problems where you just get one chance. So the problem is what happens to the graph of the normal curve as the mean increases. Okay, so let's look at this picture, which I found. Okay, so we know that the mean of the normal curve is always in the middle. So look at this pink curve. Here the mean is 0. So the pink curve will have 0 in the middle. Whereas for the blue curve, the mean is again in the middle, so it's 3. So this is on the horizontal, it's like a number line. So you see that the mean for the blue curve is more. For the blue curve is 3, and for the pink curve it's 0. And therefore, the blue curve has to be on the right in order to keep the mean in the middle. So this will always happen if the mean is increasing for normal curve, then actually the curve is sliding to the right. Okay, so let's go back. Okay, the problem was what happens to the graph of the normal curve as the mean increases. So we figured out that the graph slides to the right. And then they say what happens as the standard deviation decreases. So there again, we have a good picture. So let's go to that. So look at this picture. So we know that within one standard deviation, we always have 68% area by empirical rule. So look at the pink curve. Let's say that the standard deviation is 1. So standard deviation is 1. So for the pink curve, the mean is in this case, the means of both are 0. And the standard deviation is 1 for the pink curve. So you go 1 on the left of 0 and 1 on the right of 0. So you see that this area within one standard deviation, that has to be 68% of the total area. And now for the blue curve, the standard deviation is 2. So the one standard deviation mark happens over here on the right side of 0 and -2 on the left side of 0. So again, the area has to be 68% within one standard deviation, whether the standard deviation is 1 or 2 or 100 or 200 or 300. The area within one standard deviation has to be 68%. So since for the lower standard deviation curve, which was the pink curve, we have a smaller horizontal cover, therefore the vertical height has to increase because the total area has to be 68%. Whereas the blue curve has a higher standard deviation, it has a higher horizontal coverage, so it can have a lower peak and still have the 68% area. So the lesson we are learning here is that if the standard deviation is lower, then the curve is actually rising sharply. Whereas if the standard deviation is higher, then the curve is flatter. So lower standard deviation means steeper curve, and higher standard deviation means flatter curve. So let's see. So what happens to the normal curve is the standard deviation decreases, so the curve should become steeper. Compresses and becomes steeper. Yeah, that's what was happening to the pink curve. What are the requirements? What requirements are necessary for a normal probability density to be a standard normal probability distribution? So normal distribution can have different means and different standard deviations, but if the mean is 0 and standard deviation is 1, then it's a standard normal curve. So for a standard normal curve, the mean is 0 and the standard deviation is 1. Otherwise, if the mean is not, if either of these two things is missing, the mean being 0 and the standard deviation is 1, then it's not a standard normal curve. It could still be a normal curve, but it wouldn't be standard normal curve. Okay. So what are the requirements for a normal probability distribution to be standard normal? So mean should be 0 and standard deviation should be 1. So you know that the symbol for mean is mu and standard deviation is sigma. Both the graphs represent normal distributions with mean 10. So mean 10, see? Determine which of the two curves has a standard deviation 2 and which has a standard deviation 3. So we've already learned this idea that a lower standard deviation will mean a steeper curve and a compressed curve. So A will have the lower standard deviation because A is steeper and compressed. So A will have the standard deviation of 2. So A has standard deviation of 2, B has standard deviation 3. Since graph A is taller, it has a large, no, since graph A is taller, it has a smaller standard deviation. A has 2, B has 3. Since graph B is wider, it has greater spread and a larger, no. Okay, yeah, that seems right. But let's look at C. So C gives the wrong number. A, we know that A is 2 and B is 3. So B is wider graph, agreed. It has a greater spread and a larger standard deviation, right? We already know that. A has smaller and B has larger. So that's also one way to remember. If the graph is wider, then it has a wider spread and therefore a wider standard deviation, because standard deviation measures how much data is dispersed. Both the graphs are normal, so now the standard deviations are equal. Determine which of the two has a mean of 8 and which one has a mean of 14. So this is kind of a giveaway already. We know that the pink curve has a mean of 8 because mean has to be in the center of the curve, and the blue curve has to have the mean 14 because blue is in the center, 14 is in the center of the blue curve. So graph A has mean 8, graph B has mean 14. Since graph A is shifted to the right, no, since graph A is shifted to the left. A normal curve will be centered over its mean. That looks correct. Graph A has mean 8, B has mean 14. A normal curve will be centered over its mean. All others are wrong. You can look through them.